Welcome to this video abstract on indirect Hamiltonian estimation. So, often in quantum control you need to know the Hamiltonian of the system in order to do anything. And also from a fundamental point of view, if you want to understand the system you need to know the Hamiltonian. So we were interested in how to actually find out the Hamiltonian of a given system by performing some experiments. The question that we'd like to address here is how to do this indirectly. That means by interacting with as little of the system as possible. So we were having in mind a large quantum system coupled by some Hamiltonian, and we were thinking of what is the smallest gateway to the system in which we have to do our measurements in order to learn the Hamiltonian of the system. To give you an idea how this might work, let's consider the simplest case first. Two spin-a-half particles coupled by some interaction. How would we find out the strength of this interaction by just messing around with one of the qubits? Well, in this case it's very simple. You just introduce an excitation to the system and you locally observe how this excitation moves about in the system. What you typically see, for example in a Heisenberg interaction, is an oscillation. And then the frequency of this oscillation immediately gives you the coupling strength of the system. So what we've tried to do in this paper is to generalize this question. For example, we were considering two-dimensional lattices where now the task would be to find out all these coupling strengths here, C and M. And also we were considering the case where additionally to the couplings between the qubits you would have some magnetic field which is inhomogeneous with different strength on all lattice sides. And so the question is, what is the smallest set of these qubits, the smallest subsets that we have to address in order to learn all the couplings in the whole Hamiltonian? And we give an estimate on this number in the paper, which for example in the 2D case is just given by one edge of the system. And actually if you look at the paper you will see that we give an estimate for generic graphs. So for the details I would like to refer you to this paper.